Hello and welcome to STEM with Mr. N, where I perform different demonstrations and explain the science behind what we're seeing. This week I'm going to be showing you some cool experiments with dry ice. Let's check it out. I made a video back at Halloween showing you some Halloween themed activities that you can do using dry ice. Recently I've been performing some science shows at a local museum and I had some leftover dry ice. So I've decided to use that to make another video for you showing you some more cool experiments that you can do with dry ice. But first, let's have a bit of a recap. Unlike normal ice, which is made of water, dry ice is frozen carbon dioxide gas. Now, carbon dioxide freezes at -79 degrees Celsius, so I can't touch dry ice with my bare hands because that will cause me some severe frost burns and could even cause frostbite. So I'm going to be using tongs throughout this video. Now, dry ice goes through a process called sublimation when it warms up. This is where it turns straight from a solid into a gas. You can see here that a gas is being produced. You can see that sort of white smoke coming from the dry ice. This is carbon dioxide gas mixing with water vapor in the air. You'll notice that the gas being produced is floating towards the ground. This is because carbon dioxide gas is heavier than the air round about, so it's flowing with the water vapor down towards the ground. I'm going to use this fact about carbon dioxide gas in this first experiment. For this, you will need a bowl. I'm using a Pyrex bowl so you can clearly see what is happening. Some bubble solution. I found that dish soap and warm water worked the best. A bubble wand. You'll obviously need some dry ice and you'll need some tongs to be able to lift the dry ice. What I'm going to do is put some dry ice into the bottom of my Pyrex bowl and then I'm just going to leave it for a few minutes. After a few minutes, I'm going to use my bubble wand and my bubble solution that I've made using dish soap and warm water to start blowing bubbles into the bowl. Now, you do need a bit of perseverance for this one to see exactly what you're meant to see happening. As I was blowing some of these in, they were popping really quickly. But you'll notice as I'm blowing bubbles in, some of them are bouncing about inside the bowl before popping, rather than going straight down to the side. They seem to be skipping across another surface. This is because the dry ice in the bowl is sublimating, so it's turning into the carbon dioxide gas. But remember I said that carbon dioxide gas is heavier than the air round about, so it's filling up the bottom of that bowl with this carbon dioxide gas. The bubbles are lighter than the carbon dioxide gas, so when they go into the bowl, they are skipping across the surface of the gas before they are popping. If you manage to get a bubble to land on the dry ice, as I actually managed to, this bubble will start to freeze. After leaving it for a couple of minutes to make sure it was nice and frozen, when I went to pick it up, it actually crumbled as if it was a piece of paper. And it was perfectly safe to touch with my hands because I wasn't touching the dry ice directly. This is a great experiment which demonstrates density, how heavy something is. So the carbon dioxide gas is more dense than the air round about, and that's why it's filling up the bottom of the bowl. And the bubbles are less dense, and that's why they skip across the top. I've made videos explaining more about density before, so I'll put links in the description for you to check those out. For the next experiment, I'm going to be using some isopropyl alcohol along with my dry ice and some leaves from the garden. So all I'm going to do is put some isopropyl alcohol into a glass and then I'm going to add some dry ice into this glass. Now be careful because when you put dry ice into isopropyl alcohol, it bubbles really quickly and it bubbles quite a lot more than I was expecting, leading to it spilling out over the glass and all over the table. It's just as well I'm using a tablecloth, which is very easy to clean and it's not a problem getting some of this alcohol on it. After leaving it for a couple of minutes to make sure the alcohol is cooled down a lot, I'm going to dip a leaf from the garden into the alcohol. And when I bring it back out, it is crispy and cold as if it has been sitting out on a frosty night or frosty morning. You might be wondering why the alcohol is not freezing when I'm adding the dry ice into it, given that dry ice freezes at minus 79 degrees Celsius. Normal water freezes at 0 degrees Celsius, but isopropyl alcohol freezes at minus 89 degrees Celsius, so there's still a gap there between the freezing point of the alcohol and how cold the dry ice is. This allows me though to cool the alcohol down a lot and be able to dip these leaves in and bring them out feeling nice and crispy and frozen, like I said, as if they've been out on a frosty night. You'll also see when I dip the leaf in that a whole load of bubbles form around the leaf, and this is a carbon dioxide gas that is now infused into the alcohol as a result of the dry ice going through that sublimation process in the liquid. For the next experiment, I'm going to go outside. For this, I'm using a small empty paint can because the lid can be pressed on nice and tight. I'm going to put the lid of the paint can on the ground and I'm going to put some dry ice onto the lid. Then I'm going to put the can on top of the lid, press it down nice and tight so it's clipped on, move back out the way and watch what happens. You'll see the paint can is getting launched up into the air after a short time of sitting on top of the lid. So what is actually happening in this experiment? Well, as the dry ice is going through that sublimation process, turning from a solid into a gas, that gas is building up pressure inside the paint can. The pressure of that gas wants to escape, but the can is pressed on nice and tight to the lid, creating a good seal. Eventually, the pressure of the gas becomes too much, and that is what forces the can up and off the lid. This is like a mini rocket, and I've made experiment videos before showing you how to make different types of rocket, and this is just one other way of doing it. This paint can didn't launch very high into the air, but you can try this with different sizes of container to see what works best for launching a rocket high up into the air. But remember, you must be very, very careful when you're using dry ice. Make sure you're doing this with a parent and that you're not touching dry ice with your bare hands. You might also be wondering where you can get dry ice. I've read online that if you go to the supermarket, sometimes they have dry ice left over from their deliveries, which they might be happy to give you. I've never tried this. I get my dry ice from a supplier online and it can be quite expensive, but it's different when I'm using a lot of it for different science shows. But if you're just wanting to try these at home, find a cheaper way to do it. And remember, always follow the safety precautions. Do not touch dry ice with your bare hands. I always use tongs when I am using my dry ice. Well, that's all for this week. I hope you enjoyed these bonus experiments with dry ice. If you did, please hit the like and subscribe buttons to stay up to date on all future content. As always, I would like to take this opportunity to answer any science questions you have about any science topics at all. So feel free to email me at stemwithmrn@outlook.com and I'll get back to you with answers to your questions. You can subscribe to the channel by pushing the button here, and I've added links here to the other STEM demo and explanation videos I do, here to my STEM career interviews, and here to my series on 10 things you should know about. This has been STEM with Mr. N, exploring more cool experiments with dry ice.